Hello everyone, it's May the 6th. Alright, today was a data science day. I was trying to do a lot of data science things. I mean, the thing with data science is there are a lot of workflows, and then I don't do it very often. Once in a while, I'd say maybe once a week, I do it. And I use scikit-learn, I use Keras, but more scikit-learns. Keras didn't use that often, but sometimes, I should say every time I use it, I do use it quite extensively. And actually, last time I used Keras, I think I talk about it here. I was trying to do the reinforcement learning, the actor-critic architecture, and I did pretty deep dive into Keras, and everything is like the training loop is customized and all that type of stuff. And today I need to do Keras again. It's very simple. It was just a classifier, a simple classifier, nothing special. But the syntax and the workflow, my dear Lord, it escaped me every single time. I just, for the love of all things pure and good, I could not memorize the workflow. I have to always go back to documentation and read tutorials and just to get a sense of how the workflow goes, and then kind of feel it. And then it took me like what, a good 20-30 minutes to get back the workflow for Keras. But it's a much better experience training the model compared to using scikit-learn. As my previous experience was with scikit-learn, they have all types of classifier as well. But it's you have to set up the tuning yourself. The what's that called? The hyperparameter tuning. I forgot the name of it. No, you set apart one part of the training data as a validation, cross validation. Yeah, you have to set up cross validation yourself. I mean, it's not completely by hand, but you do have to set it up yourself, and then to run it, and it just takes tremendously amount of time to run to set things up. And then Keras is they set everything for you. It's very simple. So yeah, that was there. And now, like, I think I did my initial analysis, and now the goal is to visualize it. And I found something pretty interesting in Matplotlib. You can do something called a inset axis. Basically, I want to draw pie charts according to a pie charts on different geolocations. So I want to draw a lot of pie charts on a map, and apparently this inset axis can help me achieve that. But I haven't gone there yet because I feel like that requires another push, and right now I have more ganas to do LeetCode. All right, enough of my rambling. Let's take a look what we have today. What's this? Convert sorted list into a binary search tree. Oh, I can see this one being asked in the actual interview. Very relevant. Given the head of a single linked list, elements are sorted in ascending order, converted to a height balanced binary search tree. Oh, a height balanced search. Oh, that's not trivial. In which the depth of the two subtrees of every node never differ by more than one. Oh my. Okay. Shown height. Balance search tree 0, -3, 9, -10, no, 5. Yeah. Alright, binary search tree. Left node is smaller than the child and parent. Right child is larger than the parent. What if they're the same? I guess the same doesn't matter, right? In ascending, maybe it didn't say they're all unique though. I didn't say they're unique. Number of nodes and not value. So what do you want to, smaller and larger equal to? I actually don't know. Can we provide a simple test case? Let's see. Let's say we have a 5, 5. How about 5, 5, 9? Oh, it probably didn't return anything. That should be fine. Head must be strictly increasing. Okay. So that's fine. That's fine. So every value is unique. Okay. All right. A balanced. I mean, you're trying to build a tree. Definitely have to do recursively. Not definitely, but that's the better way forward. How would you approach it? I mean, if our node, our root is at the front, right, then it's like right biased, and definitely it's not going to work. And here is not. So the best chance is to find the middle, right? The best chance is to find the middle of the current linked list. You just like pick from the middle up. Now we have two subtrees, here and here. We know for a fact that this will be the left child and this will be the right child, because we cannot use any others to be the left child. Because if we use this as a left child, then this one is, oh, that's actually, it's fine. We can use minus 10 here. Minus 10, just put a minus 3 here. It's fine. Everything here is on the left child. That's fine. That's fine. Doesn't matter. So after we pick here, and then we have this, right? And we pick the center again. Every time we have a linked list, we always pick the center as the current root. And then this root will be the left child of him, of that node. Okay? Okay. Yeah, I think that's it. So we're gonna do, is that ON squared? Well, we have to find the center. I mean, we use two nodes. So it's ON, right? So the fast node here, slow node will be N in the middle. And once we're done, we can do the left part and the right part. I mean, the right part is easier. The left part, how do we end in this one? That means we add a dummy. We add a dummy, right? And then, so when we find the center, this one will be pointing to the end. So we have a dummy and in the end, and this will be our front, the left subtree, and this towards the end. Actually, no, it's from this towards the end will be the right subtree. And then the function will return the node, the root. Function return the root, and then I just point this to this, this to this. So we have to traverse the whole thing, and every single one of them have traverse. So that is what? O and log n. O and log n, because we divide it into 2, divide into 2, divide into 2, and each, so the dividing cost, the depth is log n, and at each level we basically have to traverse the entire thing. So I think it's O and log n. All right, we can try to write it. I have not used Vim today, so I might get a little rusty. Well, I didn't use Vim because I was coding exclusively in Jupyter Lab, which does not support. Actually, I don't know. Maybe it does support. I don't think so. I don't think it supports. So anyway, we don't have muscle memory yet. So V, no, do this. No, we don't have to. Why it stopped? Oh, what did I do? Oh, I'll have to use this. Okay, so We don't need this, and we do have to copy and paste here. There's a lot of things in the copy and paste. Well, for one thing, these we don't need anymore. Go to 5. No, just here. We're gonna go select. Go up. Actually, and that's fine. It's fine. I'm gonna uncomment these, and then 5. We're gonna comment. Nope. And also 10. We're gonna comment. Okay, so these are the tree nodes and the list node. All right, so sorted to binary. So we have a head. We always give a head, but we want to add a dummy node so everything will be easier to manage. So we do have to do a, let's say, dummy equals list node. Next equals head, right? And then I'm going to define a recursion helper function. I just call it helper function. And we're going to pass in. What do we pass in? I mean, has to be the head and tail. We have to pass in both, right? We're going to pass in head. It's going to be a list node. And tail is also going to be a list node. Actually, I can compare them directly, right? I can compare them directly. So they're gonna return a tree node, right? So head and tail. So we have head and we have tail. How do you know the tail when we start? None. Oh man. If tail is none, yeah, we can do tail is none. That's actually fine. That's actually fine. So yeah, it's actually fine. Doesn't matter. Doesn't matter. Okay. Now we have head and tail. What do? We want to traverse it, so we have basically we need 3 nodes. We need a fast, we need a slow, fast, slow, and pre. All right, fast, slow, and pre. Actually, we don't. Do we need fast, slow, and pre? We don't need, right? Because we can end in here, just like we end here in the none. This is the tail, right? This is the tail. Now, do you want this to be the tail? If this is the tail, then the condition will be the node is not equal to the tail, just like the node is not equal to the none. Maybe we don't need. Anyway, we find the center first, right? And then here we have this, and go twice, let's go once. So we actually will end up at -10 on this side, right? And I'll say, what? I'm trying to find the edge case. So at the end, we'll have the middles be here, right? The middle node is here. And this is a tail node. So I say from here, we are going to assign the head, right? The dummy and myself, the dummy, and that's the, yeah, that's the thing. That's the left tree. And the right tree will be here, okay? This is the head, the dummy, right? This is the dummy, and this is the tail. Wait, who is the tail? This is the tail. That's actually not the tail. But it does end here. No, that's the end. So we here fast go 2, slow go 1, fast go 2, cannot go 2, but it ends up here, right? So fast go 2, end up here, and slow go 1. It's actually end up at -3. I bet end up -3. So that's the root, and then the left tree will be here to -3. Right will be from -3 to the terminal node, current terminal node. So we keep going, -3 to here, right? And we say if the head, the next equals tail, right? Or head next is none, or head next equals tail. That means, because that's not included, this is not included, that means we're going to return none. That's the one condition. And here, we have start is here, end is here, and we have dummies here. So fast node, we're going to go boom, boom. Slow node coming here. So that is the root. So this one will return yes. And then left, then the right side will be this and this. So we'll return none, okay? The left side will be the head and myself, which is follow the same. So okay, so thing is if head dot next is none, or head dot next equals tail. Can we say equals tail? I guess. I mean, we're comparing the. I think when we do this, we're comparing. I mean, the value is unique. Let's just compare the value. So it'll be, it'll be more. How should I say? More straightforward, right? And then we check, right? So only the tail can be none. So if this happens, so we already checked. I think that's the only chance we're gonna hit it. Okay, so when this happens, we're gonna return none. All right. Otherwise, then we're gonna say we'll have two nodes, right? A slow and fast will equal to head and head, right? Slow and fast, and then we say while fast. How should we say fast? Because fast I go 2 times, so we have to check its next, right? And I check its next. So while fast dot next, fast dot next is not none, end, but fast, I want the fast to actually end. Hold on, let me see. Fast. We're gonna go once. Man. While fast. Because I want the fast to move forward, right? Every time fast move 2 times, the slow move once. So fast need to move 2 times. If I move 1, if fast move 1 instead of 2 times, should the slow move or should the slow not move? That actually is a good question. Like if fast can only move 1, like if fast can move only 1 time and then they cannot keep moving, should the slow still move? Let's see, fast, 1, 2, okay, 1, 2, and then 1, right? So fast go 1, 2, slow will go here, fast go 1, 2, slow will go here, fast go 1, and slow will go here. So if fast move once, a slow still has to move. But this means while fast on next is not none, yes, I think it's when fast on next is not none. Fast on next and not none, and we're gonna move, and also fast on next is not. Fast on next is not the tail, right? So these are the two conditions. If fast on next is not none, and fast on next the vowel. But if it is none, we still need to move. I mean, like this. Let's say we still need to move 2 times, right? We still need to move 2 times. It's like when fast end up here. Like if we start here, right? Fast go boom boom, boom boom. Do we go again? There's only one. We can move only once. So I have to move 2 times. So if it's slow, it will be 1 time and 2 times. I think I can choose to choose to not move, right? I mean, if it's odd number, then we can always move 2 times. Yeah, if it's odd number, we can always move 2 times. If it's even number, like 3, 0, 5, 9, then the fast can only move, can we start from dummy? So 1, 2, right, once, and then slow go here, and then 2 times, slow go here, right? That's actually fine. We can use this as the root, and fast can only do once, right? Only do once. So we say if we only do once, then we don't move. Okay, so vowel equals tail dot vowel, right? So while it's not equal to. So if it's this, then we say fast equals fast dot next, right? We can move 2 times. As long as fast on next is not none, we can move 2 times. And then slow equals slow dot next, right? Slow and move once. And then after doing that, we will end. It's not none, and fast dot next dot vowel is not equal to tail dot vowel. And the tail has to be none. How so? Or actually, this is gonna be this. Tail is not none and, right? So we have to do tail is not none and this. I feel like it's possible to combine these together. So right? So we say fast on next is none. Is not tail. But tail could be none, right? So since it's not, and then tail is not none, and it's not equal. So I do think I have to do like this. Then we can move twice, and then slow will be pointing to the root that we're gonna return, right? So we're gonna split. We're gonna split. We're gonna say how we're gonna split. We're gonna say left child will equal to helper. Head will be the same head as right now, but the tail will be the myself, slow. And the right child will be helper. Head will be slow, tail will be tail, right? And then after we're done, we can say, actually, we can return. We can directly return. We can say return a tree node, right? We say vowel equal to slow dot vowel, left equals I forgot to use the syntax. So I'm gonna go here, v this yank, gonna go up, gonna go to this, and then going to have to go 1 to the left, and then p, yeah, and then go to 31, this, w, v, this, yank, go to up, 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 so we'll go to the end, and then insert right equals p, right? And I think that's it. I'm gonna return the tree node, and of course, I'm gonna say return helper. Head is going to be dummy, right? And tail is going to be none. Okay, I'm gonna test it here. Just give it a shot. I mean, for better or worse, this can put in here. I don't have to. So it'd be like this. And run code. See what result do we get. I think I had a maximum recursion. How is that possible? I guess it is possible. Alright, we need to do some debugging here. Say if head.next is none, or tail is not none.val equals tail.val. Okay, now I return none. I don't see the problem here. Slow and fast. I say, well, fast.next is not none, and the tail is not none, and fast.next.val is not equal to tail.val. So I go twice, slow go once. Okay, and then exit tree node. Val is this left. We say head and slow. I don't see a problem there. And slow and tail. Tail can be none. Okay, how do we debug this? Helper coming in. I think we can just check. I think we just check head and tail. Check head.val. The tail can be none. So I think this is what I'm gonna do. We need a represent def represent self return f I just str, that should be fine. Str self.val, right? Self.val. Let's try. So I'm gonna print head and print tail. Alright? Let's give it a shot, see what we get. Okay, we have what is this? What is this? I have 0, none, that's true, and then we have 0, 0. Huh? 0, 0. How is 0, 0 possible? I mean, we have, no, wait, hold on. We call next equals head. Oh, the dummy value. The dummy value has to be not 0. What's the limit? number of nodes minus 10. So minus 10 to the we can actually do, let me just do minus math.inf, something like that. All right, let's see this time. Okay. Interesting. So it's good, first one, and then this doesn't work, right? So we have a fast and a slow. They're both at a head, and then we do this, and oh, I think it should be or. Right? It should be or. If this is not none, now we can go. No. No. It is and, right? So it's not none, right? And oh, tail is not none. We cannot do that. So how do we consider? So it has to be and, right? So one is the next not none, right? And another condition is not equal to tail.val if there is a tail. And if tail is none, then we only consider the first part. How do we express this? So it should be is not. So while, so two situations. Tail, if tail is none, then the condition is this is not none, right? Or tail is not none. Yeah, I think it's or. Yeah, this is when tail is none, right? Is not none. No, we have to say tail is none. So it'd be like tail is none and fast.next is not none. Or tail is not none. Yeah. How about this? I think this will be fine. All right, I'll run this. Oof. What's the condition? What's while tail is none? So now the tail is none. So we consider this, and fast.next is not none. Then I go fast equals fast.next, and it's not none. So we can do another next, right? And coming up, if while fast, we have to say while fast and, because we need to call fast.next, while fast and tail is none and fast.next is not none. This is a very complicated condition. I mean, my idea is I want to walk the fast towards the tail, but the tail could be none or the tail could be something else. Therefore, if tail is none, right, and fast, yeah, I think I can put in here. If tail is none and fast on next, right? That's one condition. Or tail is not none, then we just do this. Okay, try it again. What's this? So we have Now the represent doesn't work. Huh? How? How does the represent doesn't work? It just print out list node, val, and then next. I don't want to print out next. I just want to print out the value. But it's like str? Man. Let's go. I have an answer for this, so I wrote here. Yeah. Self.val, yeah. REPR, yeah. REPR, self.val. Why do you print other things? I don't understand. Like, why would you print all these? What is this? How about let's just print out val. Print tail or tail.val. Print head, print tail, val, if tail, else none. How about this? Yep. Okay. Now we see. So start, that's good. And then minus inf to 0, that's true. That's the first, right? And then we keep going. Minus inf to minus 10, right? So we are in this branch, and we say we're here, we go 1, 2, and then go 1, and we say but 1 doesn't count, so we end up at minus 10. Okay, so now we go minus inf to minus 10. Now minus inf to minus 10 shall fit this, right? Because yeah, minus inf to minus 10 shall fit. Next one is minus 10 to 0. Yes, minus 10 to 0. And then we go minus 10 to 0, minus 10 to 0. So we go from here, and we say fast, boom, boom, right? Fast end at 0. Fast. So tail is not none. And fast.next val is not equal to tail.val. So tail.val is 0. Fast.next is minus 3. So we say fast.next. So fast shall end up at 0 right now. And slow shall end up at minus 3. And then I say, well, tail is none. Tail is not none. Tail is not none, and a fast dot next. Oh, tail is not none. We have issue. So tail is not none, right? So we say it should be fast. When we check fast.val is not equal to tail.val, and fast.next.val is not equal to tail.val. Yeah, I'll have to check both because now I'm at the same place, right? So this we can now move. Then we jump out. Then we say, well, minus 3 should be the tree node, and the left will be head. What is the head? Head is here, and slow is here, which will return nothing. Right, it will be slow and tail, which also return nothing. Okay, let's try this one. This one has, yep, this one gives a result. Let's see if this is one of the answer. 0 minus 3, 9 minus 10, no 5. 0 minus 3, 9 minus 10, no 5. Yeah, I think this is the one. Let's remove this and submit it. Let's see. Oh, yeah, we passed. We passed. Okay, so we're gonna copy it back. Yeah, the tricky part is just to make sure. It's actually quite tricky. Took me a long time. Okay, so the tricky part is definitely the condition here. Yeah, the condition is the tricky part. Other things are fine. Doesn't matter too much. Okay, so we'll do this. Right, so return this. Actually, it's fine. Let's just put them in one line. It's easier to follow. Okay, so let's write here. I'm gonna write our summary. The idea is to always find the center node of a given list and use that as the current root. After picking the current root, we treat the left portion of the linked list as the left subtree, and the right portion, the right subtree. We use the same. We perform recursion on both portions. The tricky part for me is to identify the condition for the fast node to stop. We use the fast slow node trick to find the center. The fast node can stop either when the tail is none or not none. This requires two types of check, hence the extremely long check in the while condition. We can check for while. We can check for while because the values in the linked list are unique due to the requirement of strict increasing order. I think it's O n log n, but we're going to check to see if it is O n log n. I don't think it's O n log n. I don't know. It's the runtime is very bad. Runtime is really bad. Only with 9%. Is it not O n log n? Let's check the majority answer, see how other people solve it. Find middle. Yeah, it's the same, right? How is it so simple though? Find middle node, if head equals middle, return node, yeah. Node, I mean, I did check, yeah, I did do a little bit more check, that's for sure. left head. How do you find the middle then if you just say head? When you find middle, you always they changed the input. They changed the input. They modify the input. Wow, this method does not modify the input. 132, that's the same. That's the same. That's why. It looks simple, but you cannot change the input. How can you change the input? Right? Anyway, I mean, if it's a real interview question, definitely should ask, because if you can change the input, it will make things much easier. I shouldn't say much easier, it's just it'll be easier to write. Like, you don't have to write this gigantic condition, right? Although the condition is, it's mirror, right? It's mirror image to each other, but still. I mean, I think the issue is we did a little bit too much. They use a prenode. Like, we don't use a prenode. I mean, we don't have to use a prenode, right? We can just. Why do we use a prenode? We want to standardize. We want to standardize when we search, right? But it doesn't have to be that way. I mean, because we have a prenode. Yeah, because we have a prenode, that's why we do one layer deeper, right? We do one layer deeper. It's the same solution, but we did do one layer. Have we done before? No, it's a fresh question. Very short and concise. I think they all have to do. It didn't do. Okay, this and this. Left. Oh, you can directly do this. You can directly do it this way. So we can directly say, because we're checking on the address. Okay, so okay, that's on my side. That's not good. I think another thing is head equals tail. Head equals tail. I want to give it one more thought. Give this one more thought. I mean, it's the same thing. Same thing, but we definitely can give it one more thought. Let's go back here. Right, we don't use the dummy node. I just like dummy node too much. We don't use the dummy node. Just start from here, right? And then we just go, right? 1, 2, and boom, can now go. So 2 times. So 1, 2, go 2. So that's this. And put this as the end node. We go here, right? Say 1, 2, boom, can now go. And then we go boom, can come here. So we take this as the root, and the next one we say it's this. Head and tail is the same. How about here? Head and tail. Tail will be myself. Okay, so tail will be myself. Head will be head. So tail and a head. Okay, so the head will always be new, but the tail will be something that you cannot do. Okay, yeah, I think this one. Okay, let's try. So basically, what we're saying is, I mean, it's not. I don't think we'll have anything different in terms of. All right, can we go directly to say 43G? It's actually more. So yanked and 44G. How about this? And we're gonna P it. Oh, I think I would do too much. All right, so we're gonna change. So find this, insert. That's in solution 2. I mean, it's the same one, but no K, no K, J, and then we're gonna say to the end. It's gonna be D, deleted. So we're gonna say same concept but better implementation. Okay. So we're gonna do change this one. Nope. 0 W and say C. Find this. If head equals tail, return none. Yeah. Otherwise, we have slow and fast, and we're gonna change this condition as well. So we're gonna go here. C. Find this. While slow, no, while fast is not equal to tail, and fast.next not equal to tail, right? I will do this, then we're gonna return head slow. Yeah, I think this is correct. Slow.val, head slow, and that's not slow. That's to slow.next to tail, and then we return. We don't need to use this. I can think it just use head. Okay, let's give it a shot. Oh no, just go JJ. Okay, come here. Let's try it. Run it. Syntax error. Oh, forgot to add this. Try it again. Oh, probably syntax error. I see it. Try it again. Yeah, I think this is better implementation. Yep, better implementation. Yeah, much better implementation. Yeah, I was thinking too complicated. Oh man, this one as well. I put it in the wrong place. All right, that's it. That's it for today. We did it pretty well. 2 solutions, same concept, but the second one is definitely better. I should put reference as well. All right. Anyway, that will be it for today. I'll see you guys tomorrow. Adios.